In this lesson, we will be looking at using the distance formula to find the length of lines. We're going to do two examples. The first example will be straightforward. You've got two coordinates and we're going to find the distance between them. So in other words, the length of the line. And then for the second example, we're just going to look at where we have to work backwards a little bit, or think in reverse, as I like to say, is where they give us the length of the line, but somewhere else there's missing information that we need to find. So let's go. For this first question, there I also just copied the distance formula for you, but I suggest that you learn it and know it. We need to find the length of line segment AB. So I gave you two coordinates there. There we've got coordinate A and we've got coordinate B. And they want us to find the distance between those 2 points, so the length of that line. So we are going to find the distance between A and B. Whoops. There is our distance formula. Okay, so I'm going to subtract the two x values from one another. I'm going to start with point A. You don't have to start with point A, but I'm going to start with point A. It will give you exactly the same. So I'm going to subtract those two x values, and then I'm going to subtract the two y values, starting with my point A again. Okay, perfect. There we've done the substitution, and now we just need to simplify that. All right, so if we subtract those two, what is that? Yeah, if we take -6 and we take 7 more away, it should give us that. And then that should give us a 4, 6, and take 2 away. All right, I'm showing all my working just like you should. And if I square that, and if I square that, okay, perfect. So far, so good. Now we need to put those two together, the 169 and the 16, and that gives you 185. Now we need to just consider the rounding instruction, grade 10s, if we're going to round that off and give that as a decimal. So therefore our distance of AB, and if we put that into our calculators, I wonder what that would give us. Let's quickly have a look. I get that gives me 13.6 if I round it off there to one decimal place, and that is the distance between the 2 points, the length of the line. I just want to warn you against something over here. A lot of students, they want to split them up because you identified these two as being perfect squares. Then some students want to break it up like that. I've seen students do that. And if that was you, I want you to have a look at the video on rules of roots, our square root laws. Okay, if you didn't look at that, forget about that. Keep doing what you're doing. In the second example, let's have a look at the information that we were given. Find the value of y. Where's y? There it is. Ooh, okay, so now we've got missing information that's part of coordinate B. If the length of the line is that. So we've got the length of the line segment, so the distance between A and B were given. And now we've got missing information somewhere else. So let's just quickly have a look at finding this. So again, our distance formula, because we're dealing with the distance between 2 points, we're dealing with the length of lines. So the distance between AB, there's our distance formula. With our x values, I'm going to start with coordinate B this time. So I'm taking my 5 and I'm subtracting 1. And there's my missing y. And I am subtracting something that is already negative. Okay, watch out for that substitution. And then now we need to be careful there, grade 10s, because we have that distance of AB, so we can go plug that in there. Otherwise, we have two missing things and we won't be able to find y. So there is our square root of 97. We have the length of the line. Okay, now let's simplify. That would be 4 squared. And this one would be y plus 3 squared. I'm just showing all the steps. Okay, so that squared would be 60. Now just be mindful with this one over here. I see that a lot of students lose their marbles when squaring their binomials is not part of a good old simple simplifying question where it's just asked in a straightforward way, but when it is part of another sum. So if we square that, I find that in examples like this, that a lot of students go and say that it's that. It is not equal to that. We are squaring a binomial, so we need to FOIL it out. So this is one of those examples. If this is something that you're feeling a little bit unsure about, then you need to check out the video on squaring binomials. Squaring binomials. We don't want silly algebra errors to get in the way of you doing well with your analytical geometry section. Okay, so if we do that, we're going to get y squared plus 6y plus 9. Okay, perfect. I don't know about you, but I'm ready to get rid of these square roots and stop having to write them down every single step. Think about equations, grade 10s. With an equation, you can do what you want. Okay, almost do everything that you want. Whatever you do on the left-hand side of your equation, as long as you do the same on the right-hand side, we're good. It's mathematically sound. We are allowed. And then if we are squaring that, it will give us 97. That would be part of your rules of roots as well. And then over here, I'm just putting my like terms together there, y squared plus 6y, and then the 16 plus the 9, that will give us 25, right? Am I right there? Yes, that will give us 25. Okay, now can you see that trinomial, that quadratic equation forming over there? We need to solve a quadratic equation. So I'm going to take the 97 to the other side. So in other words, I'm subtracting 97 on both sides. When I do that on the left-hand side, I am going to get that. Okay, perfect. Now we need to factorize this. I know this is where many of you reach for your calculators, and that's perfectly fine. Maybe some of you, maybe you don't have a calculator. So if you're struggling with this idea, you need to go check out the video on factorizing trinomials. Factorizing trinomials, because there I do it with and without a calculator, both. Okay, so if we factorize this, we will get the factors of 72 would be 12 and 6, and then this one would be a plus and that one would be a minus. So therefore either my y minus 6 is equal to 0 or y plus 12 is equal to 0. So therefore y is equal to 6 or y is equal to negative 12. Now there's two solutions. We just need to have a look at if both of them are acceptable in terms of the context of the sum and what we're looking at. So if we go back to our question and we look at coordinate B there, well, coordinate B is a point in the first quadrant where our y can only have a positive value. So in this case, that would be our solution where our y is equal to 6. So therefore, our coordinate B would be equal to 5 and 6 for our y value there.